Okay, this is lesson 1, and hopefully a series of educational things that are going to explain the mysteries of modern finance and all that good stuff. So really our goals in this series will be to understand and learn about financial economics and a few subsidiary subjects, but we'll go from the theory down to the practice, or really what's practical. And a lot of this has to do, what are the limits? I mean, we hear now that financial economics is no good. The last year has proven that the efficient market hypothesis and all this sort of stuff is no good. So, well, in a sense, none of the models are completely good. It's just a question of how do you use them. So we're going to really focus on, first of all, what's practical. Yeah. Let me erase that. Practical, second thing, is what works. But really what I want you to have is it'll be better for your clients. Take care of the folks that pay you, right? Better for clients. And the whole idea here is that if you have this understanding and you're comfortable with the limits of financial economics, even if you aren't just solid on all the details, you'll be able to discuss things with your clients, you'll look better in their eyes and so forth. Another point here is we're doing this through a vehicle of models. And the real thing I wanted to mention, and I'll probably say it too many times, is there's models and there's reality. And really what a model is, it's an abstraction of this reality. And now the key is, how do you do the abstraction? Now if you do it well, clients use the models and so forth and so on. But there's the models like the HSF models, but there's also models, conceptual models, and that's one of the things that we'll talk about. Now I just want to change the subject just a hair to show you something about, don't need that, about models. And let me go back to physics, since that's a world I lived in for many, many years. And if there was a fellow named Newton who came up with a thing called a second law, and that really said that force is equal to mass times acceleration. He also came up with gravity. Not a bad job. Apple fell on his head, right? Came up with that the force on that ball is equal to its mass times gravity. Now, assuming these masses are the same, and that's been an interesting subject of analysis, by the way, whether the inertial mass or gravitational mass are the same, but it appears that they are. Logically makes some sense, but doesn't have to be. Anyway, if you stick these two together, what do you get? You get the acceleration in is equal to gravity. So it's independent of the mass. So if you do an experiment like Galileo did, and you travel over and hit the Leaning Tower of Pisa, take a little ball and a big ball and drop them, and they land at about the same time. So that was pretty controversial at the time, because people did think that gravity worked more on heavier objects than lighter objects. But that's another story. Anyway, my point is that you look at this and you think, well, okay, fine, you've learned about that. No big deal. But suppose you were the patent office and Sir Isaac shows up with this law and he wants to get a patent. And you look at him and he explains it and so forth. And you think, gee, it's interesting. So what do? Well, let's try a little experiment here. So you take, I'm drawing a little person here, and you take a piece of paper. You stick it in his right hand. And in your left hand, you take doesn't have to be the same kind of paper, but say it is, and you ball it up, and you drop it. So what happens? Well, the paper, as you know, will flutter and float and so forth like this. And this one will pretty much go boom. and hit the ground. And you say, hey, Sir Isaac, here's exactly maybe the same mass, but this one clearly lands before this one. Forget the patent. You're out of here. So you'll say, oh, that's silly because there's air resistance. If you didn't have an air resistance, this thing would drop. And frankly, I've seen that experiment. Yeah, the feather drops the same as a steel ball and all that good stuff. But there's air resistance. Oh, okay. Well, what about even look at this law here? You sit there and say, well, okay, what if I remove a force? Well, then I've got no acceleration, but if there's no acceleration or deceleration, this thing's got to keep going on forever. Nothing goes on forever. If you let your foot off the gas of the car so the engine's not providing any power, it stops after a while. Oh, that's resistance of some form. So you develop theories of resistance. So the point is, though, that this law works terrific in doing things like explaining how all the satellites work, how all the planets and so forth and so on. So it's a restricted model, but it's unbelievably robust if you know how to use it. All right. Now, let's get back. Let's talk about assumptions. Okay, we've got some assumptions. Let me change color here. Okay. Now, you're going to laugh at these, but the first one is that more dollars is worth more than less dollars. Now, you think about that. That's clearly not true for people some cases. I mean, some people give up a career of being a lucrative lawyer to be a forest ranger and so forth. But what we're talking about in finance is if you end up with more, hey, that's a lot better than if you have less. The second assumption is that the risky dollar, now obviously this has to be a dollar that's not here yet, is less valuable to you than a certain. All right, the certain dollar or less risky. If I promise you $1 a year from now and the government promises you $1 from a year from now, I got to believe the dollar from the government's a little bit more valuable, although I am extremely reliable. Okay, the third point is that the now dollar is worth more than the later dollar. And there are a couple of assumptions on this. Is really kind of the time value of money. And the other is that this says that we have positive interest rates. You don't see negative interest rates in the economy, although you might have read that a Swiss bank, or a Swedish bank I think it was, decided to set their discount rate at negative 0.5%, which is sort of amazingly ridiculous. All right, now a fourth point I want to bring up is a thing they call the law of one price. You hear it more in international currency things, but it sort of means that, you can A&P, Safeway, and Jewel all charge the same for a loaf of bread. Well, they don't quite, but you can always explain it through transportation differences. The idea here is that there is no riskless arbitrage. So you can't go easily looking around and say, oh, I'm going to buy this guy and sell it across the street instantaneously and make a profit. Because if it'll be done, and in fact that's what arbitrageurs do all the time. And they're out there working the market to make it efficient. So there's no riskless arbitrage. All right. In fact, we're starting to the next thing I really want to get into is risk, but we're running out of time. So what I want to do is to take risk, and we'll cover that in the next lecture too. Just as a quick preview, though, there's really two kinds of risks that we really work with. One are the risks that are involved with, that are unique to a company, and the others which are the market risk. That's really risks that affect everybody, the so-called systematic risks. Okay, I'll see you next one.